linear equations. Real life situations. Example 1. Telstra's rates for local calls from private telephones consist of a quarterly rental fee of $29 plus 20 cents for every call. Construct a cost function that describes the quarterly telephone bill and forwards graph. So let's think about this. This is what's happening here. You can use your mobile, it doesn't have to be your private phone bill. We better write something down first in regards to letters. So we've got to say let. Okay, and we always want to say let C equal, now this case C will be the cost, and it has to be in dollars, of quarterly bill. Here's a telephone bill, you can be more specific if you want to, and N has to be the number of calls. So there we go there. So writing our rule, we get C equals the cost. One's in dollars and the other one's in cents, but because we've said dollars here, we're going to change this. Now 20 cents is just $0.20. So we're going to pay a flat fee, that's just like your flag war, of $29 plus every call that we make is going to be 20 cents. And we said N is the number of calls. So there's our rule, and we'll quickly graph it. 1, 2, 3, and we'll go up by 5, 10, 15, 20, 25, 30, 35. That's your cost. This part here is your N. I said 5, 10. Mark in the y-intercept. The y-intercept is 29, so it's about there. Point 2, we go up by 0.2 and across 1. It's not much that we're actually moving it up, and we draw our line. The second one says tyres of a racing car lose 4 mils after completing 300 kilometres. Now we need to think about this, because which one's our X and which one is our Y? Do we lose mils because of racing, or do we lose mils, the other way around? So here, X is the kilometres that we travel, and I'll write it as X, but really I'll produce better letters, and this part, the tread that we lose, is our Y. So let's write 2 points, 304, and the other point is the 1,000 and the 5. Now because we need to write, it says assuming the load of tread was proportional to the distance covered, in other words, straight lines on the total loss of tread, T mils, they did use T, sorry, after D kilometres from the start of the race. Well, what would the tread loss be at the end of 2,000 kilometre race? So we need to find our equation. So we've got our gradient first, and that's 5 minus 4 divided by 1,000 minus 300. So our gradient equals 1 over 700. And that's fine. I'll use the rule of y equals mx plus c, doesn't matter which one you use, and I'll use the gradient there and the point 304. So substituting them in, I get 4 equals 1 over 700 times 300 plus my c. So my c will equal 4, take away, now they cancel, that's just 3 on 7. Now this will be 28 over 7, so it is 25 over 7. So therefore, my y equals m was 1 on 700, x, and my y-intercept is 25 on 7. Now, when x equals 2,000 kilometres, that's what they're asking for, what does y equal? Remember, I'm using x and y, not t and d. So I've got y equals 2,000 divided by 700 plus 25 on 7. That's just 20 on 7 plus 25 on 20. on 7, so we can write it as 20 like that, so we get 45 on 7. So which equals 6, so that's 42 and 3/7 mils of tret. Okay, I won't finish it off there, I'm running out of room. Example 3 says a car starts from point A on a highway 12 kilometres past the Windy Road post office. Car travels at an average speed of 90 kilometres per hour towards a picnic stop B, which is 130 kilometres further on from A. Let T hours be the time after the car leaves point A. Okay, find an expression for the distance D1 of the car from the post office after T hours. Well, D1 distance will be 12 kilometres that they've gone past the post office, plus, now depending how far away we want it, it will be 90, because it's travelling at 90 kilometres per hour after T hours. There's that one there. Number B, expression for the distance D2 of the car from the post office after T hours. So this one will be 130 take away 190, that's this speed times T. And it says on a separate sketch the graphs of these two and state the gradient. Well, for this one here, the gradient for this one here is again the one in front, which is 90. And for this one here, again, it's the one in front, so the gradient for this one here is negative 90. And there you have it for exercise 2E.